And today the last topic that we consider is constructors and destructors. In previous lecture we discussed about classes and objects, how to declare particular object of some class, how to work with objects. We discuss about what is the meaning of the word this. What is the meaning of this pointer? Let me briefly remind you that we can declare objects statically. Its usual way to do it, we should write the name of the class and the name of the object. Or more complex way, we can do it dynamically. In this case, we should declare the pointer to the class and using operator new allocate a memory for particular object. So in this example, I declare two objects C and B of the type complex. This is the first way, more simple, and just as example, I write another example of object declaration. I can declare a pointer P. Now P is a pointer for the type complex, and after that I can allocate the memory for one complex number. Now P points to complex. But this way of allocating memory, this way of declaring objects is used when we need to use a dynamic memory. In the most cases, it's enough to declare objects statically. These are two examples. And we discussed on previous lecture that every object has its own data and can work with their so-called member functions. The member functions implementation is common for all of the objects of the same time, but every object has its own data. When we discuss about particular object, we can say that this object has its own data, but their member functions, the functions that we declare in the object, are shared between all of their objects of particular class. This is the diagram that explains this. You can see that if there are two objects A and B of the type complex, these two objects have their own real and imaginary parts. but the implementation of the functions are common for these two objects. And the function knows which object calls this function by means of the pointer, this that points to the object that calls this method. You on previous lesson that I can write here this point re and this, sorry, not point, but arrow, this arrow im. It means that the values re and im are taken from the object that calls the function print. Here, print takes the parameter pointer to the object C. This points to C, and when I write b point print, this points to B. The program is correct. I can compile it. I can run it, and we see this result on the screen. When we create an object, particular object of some class, in some cases we can write parentheses after the name of the object. I can do it here. For example, I can write C like this. What does it mean? What is the meaning of this parenthesis? And the related question is, can we synchronize object creation with some additional actions? For example, initialization. Because in this example here, before I write C set real and C set image, the values of the fields re and im will be undefined until I call set re and set im. And the question is, can we initialize the member fields at the moment of object declaration? It's very simple to check that these fields are undefined. Let's call the function print immediately after object declaration. And we see that the values of re and im are undefined. Well, these actions can be done using special function that called constructor. Constructor is a special member function which is automatically called when the object is created. And the main functions of constructors are memory allocation, data initialization, object copying, typecasting, and so on. Today we consider maybe the most important one of these properties, one of these functions, the most important, data initialization. In our example, we will use constructor to initialize the data at the moment of object creation. Constructor is a special function, and the name of the constructor should be the same as the class name. It's identically equals to the class name. It's a first property of this special function, and another property that constructor doesn't return any result, even void. Usually when a function doesn't return a result, we write the special type void as a result to indicate that this function is without any result value, but constructor should be written even without void. Here you may see the example of such constructor, but let's write it in Visual Studio step by step. First, we should write here prototype of the constructor. The prototype, the name of the constructor, should be the same as the name of the class, complex. This constructor should get two values, re and im. These two values should be assigned as real and imaginary part of the complex number. Double re, double im, and a semicolon. So this is a prototype of constructor that can be written inside the class. If we declare this function inside the class, we should write its implementation outside of the class. And you see that I don't write here any return type. No double, no void, nothing. How to write the implementation of constructor outside of the class? The general rules, I should write the name of the class, then 4 points, and the name of the function. Now the name of the function is complex. And after that, the list of parameters. Well, you see that Visual Studio use different colors for these two words. The first word, complex, corresponds to the name of the class. The second complex corresponds to the name of the function. And in this particular case, this function is constructor. In our example, the constructor will be very simple. Just re equals to re, im equals to im. Just assign the values from parameters to the member fields. Usually, sometimes this constructor, such type of constructor, is called constructor initializer, to indicate that this constructor just initialize their member fields. Well, but when I write this constructor, after I write it, this line becomes incorrect. What happens? What happens with this slide? Let's come back to the presentation. I repeat again that constructor doesn't return any result, even of void data type. It's not possible to get a pointer to a constructor. And usually a class can have several constructors with different parameter lists. It's called a function overloading when we can declare several functions that differs one from each other by means of a list of parameters. We can provide default values for the parameters. Okay. Well, and I skip this several slides. And when I declare this constructor, I tell the compiler that my class complex now requires two double numbers when I declare it, real and imaginary parts. It means that I should specify these double numbers when I create a particular object. Here, when I write complex C and 0, 0, it means that I call the constructor with the parameters 0 and 0. And I cannot create a class without such parameters. You see that Visual Studio underlines show me this declaration of B as a mistake. And if you try to compile this program, you see the message of fail that compiler outputs you that complex doesn't have any appropriate default constructor. Default constructor means the constructor without parameters. So I must write here some parameters. Let's check it. Let's print the values, the num of the real and imaginary parts of the objects C and B after its declaration using constructor. Let's print it to the screen, and we see that these values becomes defined. C has values 0, 0, B has initial values 1 and 2. Okay, let me repeat again that if I write some constructor, compiler will output you mistake when if you try to create your object without parameters. Because if you don't create, let's comment this. Let's comment these lines, and the program becomes correct. In this case, compiler automatically creates appropriate default constructor. But this default constructor is very simple. It just does nothing without any initial values. It creates an object without any initial values for real and imaginary parts. But the program is correct. And if I run the program, you see that these values are not defined. Okay. Let's come back to the version of the program with compiler. But sometimes it's not very convenient then if we must write parameters. Parameters for any object that I declare. It will be good that if I have a possibility to create an object without parameters. In this case, I should write so-called default constructor. Default constructor that doesn't have any parameters and perform some default initialization of the member fields. Let's write one more constructor that called the default constructor. This is the simplest example of default constructor. Constructor without parameters and the constructor that does nothing. Especially this default constructor will be generated automatically if we don't write any constructor in the class. But more correct constructor can be written like this. Real and imaginary parts equals to 0. This is more correct constructor. Let's write it in Visual Studio. And let me show you two ways how we can write this constructor. First way, I write here a prototype. Now this prototype doesn't have any parameters, and I should write here implementation. Complex, no parameters, and real equals to 0, image equals to 0. Now I declare and implement one more constructor, so-called default constructor. Constructor without parameters. It means that if I create a class without parameters, in this case, this default constructor will be called. And you see this line becomes correct. This line becomes correct. And if I output the values of the object A, we see that real and imaginary part of A equals to 0. Well, this is the first way how to write a constructor. But you see that in this example, constructor is very simple. I just assign zeros to real and imaginary parts. And I can write the implementation of constructor inside the class, right here. Real equals to 0, image equals to 0. When constructor or any other member function is significantly simple, we can write the implementation of this method just inside the class declaration, like this. And the program still be correct. And you see that here there are two functions, two constructors with the same name, complex, but these constructors differs in list of parameters. In the first case, list of parameters is empty. Second case, this function has two parameters, two double numbers. Okay, some examples of default constructors. This is the example of constructor initializer. And also I told you that class can have several constructors with different list of parameters, and the compiler will understand which constructor to use. It depends on particular list of parameters that you write when you call some particular constructor. Okay, the examples that I already showed you in Visual Studio. The same examples, you may find it here in this presentation. Also, there is one more option, how to initialize the member fields. If the constructor is significantly simple, it's just initializer, constructor initializer. In this case, you can use this option. You can write initialization list after the name of the constructor. You can write like this: real 0 image 0. This notation means that I assign 0 value to real and imaginary parts. But usually this initialization performs in constructor inside this function, and initialization list we use when we work with constants, references, and so on. Well, let's consider one more type of the constructor that is called copy constructor. This constructor, according to its name, is called to create a copy of an object. The general form of this constructor is written here. First, we should write class name, and this constructor have only one parameter: constant reference to the class. This is the implementation of copy constructor. I can just move this, I can copy this implementation into the Visual Studio, and we discuss about it now. Okay, and this mistake, we should write one more constructor. Complex. Const. Complex and reference C. Complex. Okay, now the program is correct. Yes, let me write here re and in. Well, the meaning of copy constructor is just assignment of all of their members, all of the member field. We have here two member fields, real and imaginary parts, re and im. That's why in copy constructor I should take real part from this object and assign it to the real part of the object that is created. To stress it, I can write even like this. This arrow re equals to c point re. This arrow im equals to c point im. Copy constructor is called automatically when the object is copied. But you may ask me a question, when the object is copied? For example, when we pass this object as a parameter of another function, or when we return this object as a result of some function. In these two cases, copy constructor will be called automatically. And there is one form when we can call copy constructor manually. Imagine that I have two classes C and B, and after that I want to create, sorry, not classes but objects. Suppose that we have two objects C and B, and after that, after I create an object C, I want to create an object A the same as C, and I can do it using copy constructor. This line corresponds to call of copy constructor, and after that the object A will be the same as C. Let's check it, and we see that first two lines are equal. It means that the object A and object C are the same now, have the same values. Well, in this presentation, yes, the same, exactly the same that I already told you, I already show you in Visual Studio. The same is written in my presentation. I can call copy constructor when I create one object, or this copy constructor will be called automatically when I pass this parameter into the function or I return it as a result. This particular case, this explanation, maybe I'll skip it. And let's overview the copy constructors. Constructor, not only copy constructor, but all of the constructors. Constructor is a special member function that is used to create an object. There are several different types of constructor. Default constructor, constructor initializer, copy constructor. And to avoid errors, it's better to write constructor by yourself, not relying on the compiler. Because compiler, of course, can generate this constructor automatically, but these constructors, as you see, is not so good as manually written constructors. For example, it initializes the values by undefined value. Okay, and the class has also special member function that is called to delete when the object is deleted. Constructor, a special member function that is called when the object is created, and destructor is a special member function that is called when the object is deleted. The general form of destructor is this sign, twiddle, and the class name. For example, class example, and the destructor is written twiddle and example. The destructor is created by compiler automatically if we do not provide destructor manually. Destructor is called automatically for statically created object. And destructor is called automatically when we delete the object that created dynamically. Let's write the destructor for our example. Because in this example, before this time, we don't have any destructor. Compiler creates it automatically, but let's write it manually. Twiddle complex. And for our simple example, it's enough to write empty destructor. But to indicate that destructor works, let's output here just a message. A message that some message, for example, just destructor. So in our example, destructor does nothing. It just outputs the message to the screen. And let's check when we see this message. We see this message in the end of the block. We see this message at the end of the block here. But suppose that I declare a complex number A inside another block. Suppose that complex C and B are created here, but complex number A is created inside some nested block. What happens in this case? According to the rules of C language, destructor is called at the end of the block. When this object becomes
Hello, guy.
well, I have some problems with the connection. Do you hear me now?
Yes, sir.
Yeah, you hear me. Okay, because I have some problems with internet. Well, the object A will be deleted here. And we see this message here, destructor. Because the object A, the lifetime of object A, the scope of the object A is between these two figure brackets. Well, usually destructor is used to delete the memory that is allocated inside constructor. Suppose that I declare one more field here. For example, I want to assign a name for any complex number, and name will be the string. What should I do? I should allocate the memory for the name here. Name equals to new char, for example, 20 symbols. 20 symbols, it's enough for the name. Okay. And this allocation of the name I should insert in any constructor. Well, what happens? Instead of re and im, our class now has one more field, name. And this name is a pointer that points to the array of characters. And this array of characters is allocated inside constructor. It means that I should release it. I should delete it inside the structure. I should write here delete name. When the object is deleted, the memory that is allocated for the name will be deleted too. Let's check. Let's run. Yes, this program is correct. And the general rule is as follows. When we have a pointer as a class member, and when we declare, when we allocate a memory in constructor, in this case, we should write destructor manually, and we should write operation of deleting this memory in destructor. Do you hear me now? Because I have the problems with internet again. Okay. Well, we consider constructors and destructors today. Do you have any questions about it?
Yes, a lot of questions.
Well, you are welcome.
Yes, please, I would like to ask you in a short word, what can you say about constructor?
Again, in a short word.
Yeah, I mean, how can exactly how can you really sum up the function of constructor?
The main function of constructor is to initialize their member fields, is to assign initial values. This is the main function of constructor, because when I create an object, it's better to assign initial values to the member fields at the moment of creation, and we can do it using constructor. Well, more questions?
And what about destructor?
Destructor, again. Destructor is a special function that called when the object is deleted. And usually, when your object doesn't have any pointers, when you don't allocate the memory, in this case, the destructor may be skipped. But in the case when you allocate the memory in constructor, in this case, destructor is obligatory, and you should write the operation of deleting the memory in destructor. Well,
okay, sir. Please, is there any link between destructor and delete?
It's usually used together. You write delete in destructor. It's typically you should write delete in destructor. Because this, again, I repeat, because destructor is usually used to release the memory that you allocate in constructor.
Yeah, exactly.
Well, there are more questions.
But if me, I choose to not write destructor before delete, is there any problem?
If you don't write destructor, in this case, your program from the first point of view will be correct. You see that I delete this destructor, or I can maybe not delete, but let me write a comment. I delete this destructor, I commented, and from the first point of view, this program is correct. And when I run it, it's also be correct. But the problem is as follows. I allocate the memory in constructor. In any constructor, I allocate the memory. Suppose in this simple program, I declare only 3 objects. But what happens if I declare not 3, but 300, 3,000, 3 millions objects? In this case, every object will allocate the memory, but no, this object doesn't delete it because I delete this destructor. These objects will allocate the memory, and nobody will delete it. And at some time, free memory will be empty. This problem is called memory leak. In programming, this problem is called memory leak, when you allocate the memory and don't delete it. Well, it becomes clear or not?
May I ask you another question, please?
Yes, sure, we have time for questions.
Okay, sir. I would like to ask you if in C++2, a constructor is a keyword which allows people to, it's like to give a certain function to the person who would like to use the application. Is it the same?
Constructor is not keyword. Usually constructor, the name of constructor is the same as the name of the class. As you see, the name of the class is complex, so the name of the constructor should be complex. But especially this keyword constructor is not a keyword, so I can declare the variable with the name constructor and so on. So constructor is not keyword.
Okay. Destructor too, it's not a keyword.
Yes, destructor is also not a keyword because I can declare the memory, the variable with the name destructor.
Okay. So it's a part of class.
Yes, it's a part of class, and the name of the destructor and the name of the constructor should be the same as the name of the class. The name of the class complex, so the name of the constructor must be complex. If the name of the class is complex, the name of the destructor must be Tweedle and the name of the class complex.
Okay, I see now. It means that we will see the function of a constructor and destructor only in the, how I can say it, in the app.
You can declare it only in the class. Only in the
Exactly,
class.
but if I want, can I write the name constructor or destructor just to?
So
Okay.
again, constructor and destructor are special functions. These functions are called automatically. You should not call programmer don't call these functions. Don't call constructor, don't call destructor. These methods, these functions are called automatically. Constructor is called when you declare the object. Destructor is called at the moment when the object is deleted.
My last question, please, sir.
Okay.
How many objects do we have? We have struct, we have constructor, we have destructor. We have just three. We have more.
Sorry, I don't understand your questions.
I would like to ask, how many classes do we have?
How many classes? Or what?
Exactly.
How many?
Like we have constructor, we have destructor, we have struct.
Or
it's just three for the moment.
okay, it's different notions. Class, struct, constructor, and destructor, because we consider only very beginning. We consider just a few just some few things from object-oriented programming. There are a lot of new possibilities in C++ that we don't consider yet, and you will continue study C++ on second course, and you consider some new topics of C++ on the second course.
Okay. And what is the main target of OOP?
Of object-oriented programming, the main goal is to create a large and very large programs. To develop medium-sized programs, it's enough to use functions, but to develop very large programs, functions is not enough, and programmers use classes.
Okay, thank you, sir.
Okay, well, we have 10 minutes, and during these 10 minutes, maybe I close the presentation. I stop sharing, and also.
Professor, may I ask you about one question about the exam?
Okay, I just want to say about the exam, and after that, you ask me if you don't understand something.
Thank you. Yeah.
Well, about your exam, you will have an exam. I don't remember the date, but you will have it in your schedule, in your timetable. And on this exam, you will have you will have two problems that I'll give you. As on test, it's similar on the test that you will have this winter. I'll give you two tasks, two problems. You will solve it. You show me your solution with your comments. I ask you to show you these solutions online. Of course, I ask you to download these solutions on Google Drive, And at the same time, on exam, I ask you to show me your programs online, like I show you my program for you. I ask you to show your programs for me. And if you solve these 2 or maybe 3 tasks correctly, you will have good mark, 4 or 5. If you don't solve it or don't ask, or maybe you solve it with some mistakes, you will have, if the problem you solve it but with some mistakes, you will have satisfactory 3. And if you don't solve these problems, you will have bad mark 2. Well, any questions about our examination?
Professor, I'm just wondering if are we gonna have to turn on our camera during the exam? Just
Yes,
prepare
I will ask you to turn on your cameras. I want to see you on exam.
Okay, so we have to prepare our camera.
Yes, on exam you should turn on your camera. You should show me your face. That I'm sure that it's your answer for me, but not your friend or maybe somebody, some other student.
Thank you.
So please, sir. Hello, sir. Is it possible to have some exercises to prepare ourselves to exam?
The exercises on exam, the tasks on exam will be exactly the same as you consider on practice. So you should just review all the exercises from the practice. And before exam, I ask your practice teacher to send me the list of the problems, and she prepare this list. Again, I repeat that these problems will be the same that you solve on practice. No new problems. Just the same problems that you solve on practice.
Okay, thank you. So, sir, we'll have OP2.
Yes. Yes, one question will be on about classes.
Okay, thank you.
Well, no more questions. Okay, let's finish our last lesson today. And our next meeting is will be on consultation. You have your schedule, and before 1 day before your consultation, I will send you the link to their Teams, the link to the meeting, and we meet on consultation. Goodbye. See you on consultation.
Okay, goodbye.
До свидания.
До свидания.
До свидания.